talk about systems of equations in three variables. Now, when you were in Algebra 1 and also the beginning of this course in Algebra 2, you did systems of equations in two variables. And what that meant was you had an equation of a line like y is equal to x plus 3, and then something like y is equal to negative 1/2 x plus 7. And you found where those lines intersected. They intersected at a point. So there was one solution. And you would have something like a coordinate where you'd have something like 2, 4. That would be your solution, your point of intersection. Okay. Now, in systems in three variables can have either one solution, infinite solution, or no solution. So there are going to be three different variables. So instead of having a coordinate with two numbers there, you're going to have three numbers. Now, if you look at the examples here, this is where you're going to have just one solution, again, where they meet. So if they meet in one spot, all three planes, then you're going to have one solution. If you have an infinitely many solution, you're talking about where the planes intersect just in one line. So these planes intersect where that black line is. So there's an infinite number of points on that black line. Another way we can have infinitely many solutions is if the planes were all lining on top of one another. Similar to when we work with lines, if we had one line and then we had another line right on top, we would say the number of times they touched would be infinite. So that would be infinitely many solutions. The same thing holds true with the plane. If I had all three planes on top of each other, then they would touch each other infinitely many times. Now, you can have no solution where all three planes they're not meeting. There's a variety of different ways that they can be placed where they are not meeting. So that's no solution. We're going to concentrate on just one solution. So let's look at the first one. So in the past, you've done two equations with two variables. We now have three equations and three variables. So the first thing we have to do is we're going to have to break this up. There's not like a magic formula where you can do it all at one time. If I look, I do notice that this y is all by itself, right? We just have one y. So that equation is going to be kind of my linking equation for this one. So what I'm going to do is I'm going to try to eliminate that y. So that I'm just dealing with x's and z's. And then I have basically what we've worked with before, two equations, two variables. Okay, so the first thing I'm going to do is I'm going to rewrite that equation. And then I'm going to start with the equation below. 5x minus 3y plus 3z is equal to 31. So now how do I eliminate that y? Well, I'm going to multiply everything by 3. And I have negative 12x plus 3y minus 15z is equal to negative 108. Now again, I will rewrite that bottom equation. And I realize that my y zero out, which is what I want. That was the whole point, right? So I have negative 7x minus 12z is equal to negative 77. So I'm going to come back. I'm going to star that equation. I'm going to come back to that one. Okay, so now I have to go back to my original again. So last time I worked with the second and the third equation. So this time I'm going to let's work with the first and the second equation. Okay, so I'll rewrite the first equation, 3x minus 2y plus 4z is equal to 35. And then underneath I'll do the same thing. I'll write the second equation. And again, the idea is I'm going to try to get rid of that y. I'm going to try to eliminate that y. So I'm going to multiply everything by 2. So I have 3x minus 2y plus 4z is equal to 35. And then I have negative 8x plus 2y minus 10z is equal to negative 72. So that gives me negative 5x minus 6z is equal to negative 37. And I'll star that one. Now, if you look at my two equations that I solved, I have x and z there. So now, again, I'm going to combine those. And I have negative 5x minus 6z is equal to negative 37. And I have negative 7x minus 12z is equal to negative 77. And I realize if I multiply, now this should be a comfort level for you at this point. I multiply the top by negative 2. That's going to be helpful. So I have 10x plus 12z is equal to 74. I'll rewrite my other equation. And I realize I have 3x. Again, my z's zero out, which is what I want, is equal to negative 3. So that gives me x is equal to negative 1. Now, once I have x, I can find y and z. So it doesn't matter which equation you go to work with. So I'm going to go up top here, and I'm going to work with this equation. So I have negative 5 times negative 1 minus 6z is equal to negative 37. So that gives me 5 minus 6z is equal to negative 37. So negative 6z is equal to negative 42. So z is equal to positive 7. Okay, last one now, I need to solve for y. So again, I can use any equation that I want. So let's go, I want to work with this first one. I'll go back to this first one here. So I have 3, and I know the value for x is negative 1, minus 2y, my y is unknown at this point, plus 4 times 7, which is z, is equal to 35. So this gives me negative 3 minus 2y plus 28 is equal to 35. So I have negative 2y plus 25 is equal to 35. So negative 2y is equal to 10. So y is equal to negative 5. Now, when we write these, we need all three variables. So I'm going to put it in coordinate form. So I have negative 1 is x, negative 5 is y, and 7 is z. So again, I write them in alphabetical order, and that's my solution of that system. Now let's look at our next example. So again, I have 3 equations, but none of the variables in any of those equations is just have a coefficient of 1. So I just have to decide, I'm going to eliminate one variable and just kind of go with it. So there is no right or wrong. You just kind of have to decide. So I'm going to use the first equation, 8x plus 3y plus 6z is equal to 43. And then I'm going to do the second one, negative 3x plus 5y plus 2z is equal to 32. So I realize if I multiply the bottom one by negative 3, I should be okay. So I have 8x plus 3y plus 6z is equal to 43. And then I have 9x minus 15y minus 6z is equal to negative 96. I add my terms. I have 17x minus 12y. Now my z zero out, which is the point, is equal to negative 53. So again, I'm going to come back to that one. That one is my equation that has only 2 variables. So now we'll go back up to the top, and I'll deal with the second and the third. You can really work in any form that you want, which, pair them any way you want. So I'll just do I'll do the second and the third. I could have used the first again if I want, but I have negative 3x plus 5y plus 2z is equal to 32. And then my last equation of 5x minus 2y plus 5z is equal to 24. Now, when you did this the first time, it didn't matter which variable you got rid of. You just picked one and you went with it. Now, we're trying to get rid of the z because I know that I want to go back and I want to match up like this. So I'm going to multiply the top equation by 5 and the bottom equation by negative 2. So it gives me negative 15x plus 25y plus 10z is equal to 160. And then I have negative 10x plus 4y minus 10z is equal to negative 48. Draw my line. I have negative 25x plus 29y is equal to 112. Now, just like our other equation, we had eliminated letter z, so now we can work with these 2 equations together. So I'm going to rewrite the other one underneath. 17x minus 12y is equal to negative 53. Now, there really is no good number to use here that's an easier one more than the other. So we're going to go pretty high number there. Multiply the top by 25. Multiply the top by 17. and the bottom one by 25. So I end up with negative 425x plus 493y is equal to 1904. The bottom equation will be positive 425x minus 300y is equal to negative 1325. So that leaves me with 193y is equal to 579. So y is equal to positive 3. Okay, so now I need to find x. X is next. So I can go either to this equation here, where I have the x and the y, or my other equation, which is right here. So I'll do this one. I have 17x minus 12 times 3 is equal to negative 53. So that's 17x minus 36 is equal to negative 53. 17x is equal, I add 36 to both sides, I get negative 17. So x is equal to negative 1. All right, need to find my last variable. So I can use any of the three equations I started with. I'll use the first one. So I have 8 times negative 1 plus 3 times 3 plus 6z is equal to 43. So that's negative 8 plus 9 plus 6z is equal to 43. So it's 1 plus 6z is equal to 43. 6z is equal to 42. So z is equal to 7. So our final answer there in coordinate form is negative 1, 3, and 7. All right, last one. Everyone loves a good word problem. So here we go. Seats closest to an amphitheater stage cost $30. The seats in the next section cost $25, and lawn seats are $20. So let's think about that. It does make sense, right? That anything close will cost more anytime you've been to a concert or any sporting event. That makes sense. There are twice as many seats in section B as section A. That might be important, along with our prices. We also know that there's 19,200 seats. It says when all 19,200 seats are sold, the amphitheater makes $456,000. How many seats are in each section? So again, there's a lot going on. So we know we have three variables, which are marked over here. We're going to make x is equal to $30, the number of $30 seats. Y is the number of $25 seats. And z is the number of $20 seats. So let's first talk about the number of seats. We'll do a quantity. So when I add them all together, x, y, and z, I know it's 19,200. Now, if we talk about a money equation, we know $30 times the number of seats, which stand for X, which is the ones closest to the stage. And then we have $25 seats times Y. And then we have the $20 seats times the number of ones in the lawn. That total amount was $456,000. Now, I only have two equations, but I have three variables. I need one more equation. Well, if you look up here, twice as many seats in section B as there are in A. So we need an equation for that. So we have y is equal to 2x. Twice as many in section B as there are in A. So that means we need to multiply what's in A to make them even, right? So now we do have three equations. This one right here, this is going to make our life a lot easier. That's why this one's a little different. Makes our life a lot easier, even though those numbers are really high for us to deal with. Okay, so let's start over here. So I'm going to replace y with 2x. So I have x plus 2x plus z is equal to 19,200. So it's 3x plus z is equal to 19,200. So I've already narrowed it down to just two variables. Okay, I'm going to do the same thing in that second equation, right? I have 30x plus 25 times 2x, because that's what y is, plus 20z is equal to 456,000. So I get 30x plus 50x plus 20z is equal to 456,000. So I have 80x plus 20z is equal to 456,000. Okay, so here's my two equations. I have an x and a z in both of them. Okay, so I'm going to rewrite them. So I have x, I have 3x plus Z is equal to 19,200, and I have 80X plus 20Z is equal to 456,000. Now, I'm going to try to get rid of that Z. That looks like that's going to be the easiest to me. Multiply the top by negative 20, and I get negative 60X minus 20Z is equal to 19,200. And I have 80X plus 20Z is equal to 456,000. Oh, wait a second. I just realized I forgot to multiply that 19,200 by 20. I go back. Let's go back and fix that one. That becomes 384,000, negative 384,000. So when I add them, I get 20X is equal to 72,000. So X is equal to 3,600. And then I also know that Y is equal to 7,200. Okay, so now we will take our two values and let's figure out what Z is. We can go back and let's use this equation right here. I have 3X, which I know, let's back up. Sorry, I know 3X. I know what that 3 stands for, 3,600, plus Z is equal to 19,200. So that's 10,800 plus Z is equal to 19,200. So Z is equal to 8,400. So in the end, we know that we had, let's see, X is 3,600. They were section A. Seats, they were the $30 seats. And then my Y is 7,200, and that's section B. And they are my $25 seats. And then I have 8,400. They are my lawn seats. And they are $20. So that is my final answer. Now I could check everything here, substitute it back in using the dollar amount and the quantity, which we saw in the beginning, to make sure we are okay. All right, thanks. Great job today. I know that was a lot of writing. Have a good one.